All right, guys, we're on the back side of Unit 8, Day 1 notes, and we're going to add and subtract radicals. So what we have to remember is that in order to add and subtract radicals, they have to be like radicals, all right? They have to have the same number underneath the radical in order to be like. So most of the time, you are going to have to simplify the radical first. Because when you simplify, the number underneath the radical changes. Okay, so if the number underneath the radical is not the same, you have to simplify the radicals first. And then only like radicals can be added and subtracted. Okay. When you add and subtract them, you're going to add and subtract the coefficients, which are the outside numbers. And you're going to keep the common radical, which is the inside number. Okay. Just like if you were to do 2x plus 3x, you get 5x. Because they're like, because they both have x's, you just take the number out in front, take the number out in front, add those numbers, and that's how we get the 5, but notice that the x stayed the same, okay, because it's like. All right, same thing goes with subtraction, all right? Now, if you had a 2x plus a 3x squared, those can't be added because they're not like, because they have different exponents on their variables, so it makes them not like, all right? So you can't put them together. All right, so here we go. We're going to add and subtract these. So in the number 1, you're going to see 7 square root of 5 plus 3 square root of 5 is 10 square root of 5. Because they already had like radicals, we didn't have to simplify them first. Okay? And then this is finished. In number 2, same thing happens. 4 square root of 3 minus square root of 3 is going to give you 3 square root of 3. All right, because they already had like radicals, that's why we can add or subtract their coefficients. For this one, we had to remember that there's a 1 here, and that 4 minus 1 is that 3. In number 3, we can't add those. Square root of 12 plus square root of 18, they're not like, so they don't go together. However, if we go and use the same process that we had in the front, where we simplify them, they might go together. So square root of 12, if you remember, the largest perfect square that goes into 12 is 4, and that makes the other number 3. If we go ahead and we circle the square root of 4, it becomes a 2. Now we have 2 square root of 3. I'm going to carry this plus sign down, and we're going to do the same thing with square root of 18. Largest perfect square that goes into 18 is 9, and the other number is 2. And we'll go ahead and circle the square root of 9, and it becomes a 3, and the square root of 2 comes down, and so does our plus sign. And now we can add them together, although you're going to see that because these are not the same, they're not going to go together. And so this is as far as we can go. We simplified it, all right, but we couldn't add them together. And sometimes that happens when that number underneath the radical isn't the same. Okay. Number 4, we cannot add these together right now because they have different numbers underneath their radicals. So we'll go ahead and simplify them and see if we can get them to be the same. So the largest perfect that goes into 20 is 4. The other number is 5. We'll go back and circle the perfect, and it becomes a 2 square root of 5. Keep the plus sign. And if you notice, first off, there is no perfect square that goes into square root of 5 besides 1, but 1 does not help simplify our radicals. And so this will just keep coming down. And now they will be able to go together because they are like radicals. They have the same number underneath the radical. So 2 square root of 5 plus 2 square root of 5 is 4 square root of 5. And that's simplest. Okay. Number 5. Right now we can't simplify or add them together, so we're going to have to simplify them first. And the largest perfect square that goes into 75 is 25, and it goes in 3 times. And we'll circle our perfect, and that becomes 5 square root of 3. We'll keep our plus sign. And 147, the largest perfect square that goes into 147 is 49. And it goes in 3 times. And we'll go back and we'll circle our square root of 49. And that's going to become 7 square root of 3. And now that they both have square roots of 3, we'll be able to add them together. So 5 square root of 3 plus 7 square root of 3 is 12 square root of 3. Okay. All right, so number 6. Right now we can't subtract them because they have different numbers underneath their radicals. So we're going to go ahead and simplify and see if we can get them to be the same. So this 3 will stay. 200. The largest perfect square that goes into 200 is 100, and it goes in 2 times. Okay. We'll circle our perfect, and that's going to become a 10. Square root of 2 comes down, the 3 comes down, and remember there's multiplication in between, and so this becomes 30. Square root of 2. We'll keep our minus sign, and 2 square root of 18. We'll keep the 2. The largest perfect that goes into 18 is 9. The other number is 2. We'll go ahead and circle our perfect, and that's going to become a 3. Everything else just comes down. And remember, there's multiplication in between there. And so 2 times 3 is 6 square root of 2. And now that they have the same square root of 2, I can go ahead and subtract them. So 30 square root of 2 minus 6 square root of 2 is 24 square root of 2. All right. Let's check out next 3. In number 7, right now I can't subtract them. They have different numbers underneath their radicals. So we're going to go ahead and try to simplify them. So the 5 stays. 12 gets broken up into 4 and 3. The square root of 4 is 2, which then becomes 10 square root of 3. Keep the minus sign. Okay. And we're going to do the same thing with 2 square root of 27. 2 stays. Largest perfect that goes into 27 is 9, and it goes in 3 times. Circle our square root of 9. It becomes a 3. Everything else comes down, and then that becomes 6 square root of 3. And now that they have the same square root of 3, we can go ahead and subtract them. So 10 square root of 3 minus 6 square root of 3 is 4 square root of 3. Okay. Number 8. Again, we can't subtract them. They have different numbers underneath their radicals. So we'll keep the 2. We'll break up 200 into 102. We'll circle our perfect square. It becomes 10. Everything else just comes down, and that becomes 20 square root of 2. Keep the minus sign. And we'll do the same thing with 2 square root of 45. Keep the 2. Break up the 45 into 9 and 5. Circle our perfect. It becomes 3. Everything else comes down, and that becomes 6 square root of 5. And we're going to notice that these are different, and therefore we are finished with this one. They will not go together. Okay, number 9. We have a negative. Square root of 12 is going to get broken up into 4 and 3. We'll circle the square root of 4. That becomes 2. All right, keep the minus sign. And this is already as simple as it goes. So it's just going to come down. Doesn't have to get broken up. The only perfect square that goes into 3 is 1, and that doesn't help us simplify. And we don't need it because we already have square roots of 3 underneath our radical, and so now they're alike, and they'll go together. So negative 2 square root of 3 minus 3 square root of 3 is negative 5 square root of 3. All right. Last 2. Even though there's 3 of them, it's no different. Same process. Right now, they won't go together because they have all 3 numbers underneath the radicals are different. And so we just have to do it 3 times. So we'll keep the 5. 18 is going to break up into 9 and 2. Square root of 9 becomes 3. Everything else comes down, and that becomes 15 square root of 2. Next up is a minus sign that comes down, and square root of 12 gets broken up into 4 and 3. Circle the perfect. It becomes 2. Everything else just comes down, and that becomes 4 square root of 3. Keep the minus sign, which comes next. And then square root of 27 gets broken up into 9 and 3. Circle our perfect. Square root of 9 becomes 3 square root of 3. And I'm just going to bring that down. And we're going to see that not all 3 of them will go together because not all of them have a 3 underneath the radical. And so 15 square root of 2 will just come down. It's not like any of the others. However, these ones are like. And so we have negative 4 square root of 3 minus 3 square root of 3, which is a minus 7 square root of 3. And that's as far as we can simplify it. All right, let's take a look at number 11. In the first one here, square root of 5. can't be simplified. The only perfect square that goes in the square root of 5 is 1, and that doesn't help us simplify. So I'm going to just keep that. However, square root of 20, largest perfect that goes into it is 4. If I circle my perfect here, that becomes a 2 square root of 5. This can just come down with it. Okay, and we're going to have our plus sign next. In the square root of 125, largest perfect that goes into it is 25, and it goes in 5 times. And then we'll circle our perfect. That's going to become 5, square root of 5. And now you can see they all have a square root of 5 underneath their radical. And so now we can go ahead and take the coefficients and add and subtract them. So we have negative 3 square root of 5 minus 2 square root of 5, which is negative 5 square root of 5, plus our 5 square root of 5 here. And so negative 5 square root of 5 plus 5 square root of 5 is actually 0 square root of 5. And 0 square root of 5 is the same thing as 0. And that one is finished. All right. Be careful on that one. Don't say 1 square root of 5, because 1 square root of 5 is square root of 5, which is not the same thing as 0. All right. I will see you guys on the next day of notes.